everyone. In this video, we will learn about multi-version timestamp ordering, which is a protocol in transaction processing, which we learn in database management system. Here we have a transaction T1 and T2. So the schedule contains two transactions T1 and T2, and these are the various instructions run by these transactions, and these are the various steps which we have in which we will be reading these instructions. Each of the transaction has a timestamp, and this timestamp of T1 is 5 and the timestamp of transaction T2 is 10. In multi-version timestamp ordering, we have three things to store. First is the data content or the data item which we want to read, the write timestamp denoted by WTS, and the read timestamp denoted by RTS. Initially, when no transaction has read or written it, these values will be 0, and the content, say it is initially the content of the item X is X0. At step 1, T1 executes read X. So whenever there is a read, then there are two conditions which are to be true. The first is if RTS is less than TST. So RTS here is 0 and TST for transaction T1 is 5. The first condition is true. So what we do? We update RTS is equal to TST. So this RTS will be changed to the TST, that is 5. So here we have changed the value 5 and rest is the same. The next instruction is write X, which is given by a transaction T1. So whenever there is a write instruction, we follow three different rules. At this particular case, what we observe is this third condition TST, if TST is greater than WTS. Here WTS is 0 and the TST of the transaction executing this write instruction is 5. So the third condition is true. So what we do, we create a new version. So the new version of X0 is created as X1. Along with this new version, what we do, we change both WTS and RTS is equal to TST. So both these values, write timestamp and read timestamp, will be now updated to the transaction who is executing the write X. So this is 5. So both these values will be changed to 5, updated to 5. Now the next instruction is a read instruction by transaction T2, and whenever there is a read instruction, we follow these two instructions. This time, this condition RTS is less than TST. RTS here is 5, but the TST of the transaction executing the read is 10. So what we do, we just follow this first rule that we update the value of RTS is equal to TST. So this value 5 of read timestamp is updated to 10 because this transaction is executing the read, and because it will definitely read the newer content. So the newer content is X1 and WTS itself is 5. So there is no change in that, but this transaction will definitely read the updated contents. Now the next instruction at step 4 is write X by transaction T2. So whenever there is a write, then we have the three different rules. Now because once again this condition, if TST is greater than WTS, earlier we have WTS is 5 and TST is 10. So TST is greater than WTS. So what we do, we once again modify the content of the database, and it is now equal to X2. And whenever we create a new version, we update both the WTS and RTS with equal to the TST of the transaction executing the write instruction. So they are now modified to 10 and 10. Now the next instruction is a read instruction by transaction T1, and whenever there is a read instruction, we have these two rules, but this time the RTS is greater than TST. See, RTS is 10 and the TST of the transaction which wants to execute the read is 5. So this condition, second condition holds true. So what this transaction does, it reads an older version of X. So the older version of X, which older version, where this RTS was equal to the TST. So this RTS is equal to TST at this particular place. So it reads X1 5 5. So here it reads X1 and keeps the value of WTS and RTS as 5 and 5, and it does not update anything. So it reads an older version where TST is equal to RTS. Next, at step 6, we have a write X instruction, and whenever we perform a write X instruction, we check the latest version of X, because from there we have to update. So the latest version of X is X2 10 10. So we have written this X2 10 10, but this time the first condition TST is less than RTS. TST of this transaction is 5, and this is executing the write, and the RTS here is 10, TST is 5. So what this first condition holds true, so this will roll back. So since this condition is here is not satisfied, so there is no new version or writing the content, but this first condition makes this transaction T1 to roll back. Now since T1 roll back, at some point of time we have read the transaction T2 reads the content written by T1. So if T1 roll backs, T2 also roll backs. So since T1 had aborted, T2 has to abort as it had read the contents written by T2. Now if this write was performed not by transaction T1 but by transaction T2, it could not have rolled back and the things have continued working. So what the crux is that if there is only a transaction gets a chance to write only if it is an older transaction. So T1 got chance to write at step 2, but once a new transaction has written it, now that chance of writing goes to the newer transaction. So older people have right to write only once, and once a new transaction writes that content, then they cannot write. And in case if they want to write, then all the transactions update. Now if this write was not there but this write of transaction T2 was there, then what we have to do is there are so many versions of X, X0, X1 and X2. So if we have to remove those, then those versions can be removed. So remove version of X0 and X1. So which versions can be removed? We can remove those versions where the write timestamp is less than the least timestamp. So the least timestamp here is 5 and here write timestamp is 0, here also write timestamp is 0. So these two versions of X can be removed. Now the multiversion, why are we studying this ordering scheme? Because it has some desirable property that a read request never fails. As we have seen at step 5, read instruction was executed properly by the older transaction. So older transactions can always read with the help of multiversion timestamp ordering and they never fails and they are not allowed to wait. But this protocol has some undesirable properties also. First is, as you have seen, whenever we read, here is a read instruction, we are updating the timestamp. Here is also a read instruction, we have once again updated the read timestamp. So whenever we have a read, then the updating of our timestamp is always required, and so this updation requires 2 disk accesses and rather than 1. Second is, if the first transaction rollbacks, all other transaction rollbacks. So the conflict between transactions are resolved through rollbacks rather than through wait. So we are not allowing transaction T1 to wait, but instead we are rollbacking, allowing it to roll back. So if it rollbacks, then T2 also, this is called as cascading rollback. So third is, it does not ensure recoverability and cascadeness. So these are 3 shortcomings of this particular protocol. Thanks for watching.